So welcome everyone to this session about a platform that delivers capability that may well be very useful to this community. And in order to be effective, I will not show many slides and make it mostly a demo, basically. Just to tell you what this technology is about. So the aim of Rosetta Hub is to connect the dots between all those technologies that you heard about, that you consider as being high potential for you, but those technologies are fragmented. Somebody has to connect the dots, and that's what we try to do. So connecting the dots between what? Clouds, containers, research software. This includes R and Python and Scala and everything that would allow you to interact with data. Real-time collaboration frameworks, things that allow you to do collaboration the Google Docs way, and social portals, things like ResearchGate that allow you to share artifacts effectively. So what Rosetta Hub delivers is, first of all, a virtual environment for research and education, an API. This is 700 plus functions that you can call from R, and that allow you to interact with all of these clouds, containers, tools, and to share and reuse. And a marketplace, this is a place for sharing. Basically, everything you produce, any data science app, any artifact that comes out of the platform can go to this marketplace to be discoverable, to be accessed and acquired and used by your peers or your students. The key concept or the key requirements of the platform are, first and above all, usability, reproducibility, shareability, and auditability of everything you do, and at all the layers of interactions. In order to achieve usability, we created a meta cloud. Basically, this is like putting a wrapper around Amazon EC2 and Google GCE and all your private clouds, and making all of them obey to the same API and to the same administration consoles. So you have a container, you say, okay, I'd like this container to be on Amazon, and that's the duty of Rosetta Hub, to get it to run where you want, where your data lives, basically, in general. We would like all those clouds to be controlled by a collaboration portal. Basically, we don't want you to put your hands in policies and rules and in all the IT stuff that you find when you touch Amazon or you touch the cloud of Google. Basically, the idea is really to be able to say, these are my friends or these are my students. I would like to make them access this environment I prepared with R and RStudio and Jupyter Notebooks or whatever. We would like you also to be able to work with R and Python and Scala all together simultaneously, as if they were the same thing. We would like to build meta kernels where in memory R and Python and Scala share their variables and look and feel as if it was like one single tool for data processing. We would like all your tools to be accessible from mobile devices. Your iPad could be your window to the clouds, to the containers, to R, to Python. We would like you to be able to use spreadsheets, but not the Excel way, in a way that is reproducible, traceable, and auditable, by combining the spreadsheet paradigm with the notebook paradigm into one place and make all that collaborative, of course. We would like also your Excel to improve and to become backed by containers. So basically, Excel would have formulas that are actually rooted into an R or Python or Scala engine, living inside a container, living somewhere in a cloud, so that everything you do in Excel is actually captured and goes back to something where your data processing is traceable. We would like you also to be able to easily create bundles of different artifacts that would recreate like your Shiny app. Imagine a complex Shiny app built with many packages, using Spark, and needing to access complex data sets. You would create a bundle, like a box, inside which you put all the deep dependencies. And within the box, you put your keys for running stuff on Amazon, for example. And then you tell Rosetta Hub that that box should be accessible to the reviewer of the journal, or to your students, or to your peer collaborators. So they go to Rosetta Hub and say, someone shared with me a box. Make that box become a Shiny app or a service or a tool that I will be immediately using. So this capability of putting together all the dependency and making them become a service actually is extremely powerful and leads to the idea of the marketplace that I will show you later on, basically. Everything should be shareable. One link, make your Shiny app or your workbench accessible to anyone, anywhere. So, and just one word, basically, in order to put the fuel into this platform, you need to have access generally to a public cloud. So we partnered with Amazon around the AWS Educate program, and we are helping institutions, educational institutions and research laboratories acquiring for free credits for their members in order to use Amazon. So the Amazon technology becomes accessible freely, and so is ours. And putting them together gives you actually a platform that monitors everything that happens within your institution. So you can see the students' consumptions, you can see the resources they are using. You have like a dashboard overlooking entirely all the infrastructure and everything that is happening, and you can really follow up and administer things extremely effectively. Currently, we are managing almost $500,000 of Amazon credits for about 40 institutions, and we have more or less 4,000 researchers, educators, and students. This is just a first proof of concept. Phase 2 will be more massive. And phase 2 will go through this link. So just write it down somewhere, edu.rosettahub.com. If you are a student, a teacher, a researcher, you can register here. If your institution is not there, you can register in your institution, and then you will receive those credits and you receive access to that monitoring capabilities of Amazon to make the cloud work for your institution and to make the cloud become a data science cloud where you deploy your Shiny apps, where your students can have their RStudio sessions at scale and in a secure way. So moving back to the demo, here we go. So I am connected here as Kareem to this portal. The link is www.rosettahub.com. What I can do once connected, so I arrive on this dashboard here. In this dashboard, I can see many artifacts running currently on multiple clouds. So if I go to machines here, I can see that I have all these. Some of them are running on EC2, some are running on Google's cloud. One of them is actually my local virtual box machine that I'm remote controlling from this platform. So in order to connect to, or to create a new one, all I need to do is to go through a very simple workflow, which is the same for all the clouds. So this workflow will ask me for my keys. I could choose to give my keys to the cloud of Google or to any other cloud. Oops, here we go. I can choose to work locally. I can choose among several options here. I'm going to specify a label for my machine. Let's call it useR. I will choose an image. There are images that are pre-prepared, but you can create your own. Then you can choose a capacity. We have mapped all the capacities of all the public clouds. Now I am going to say this machine should be shut down manually. I can keep on configuring and say the containers inside this machine should have these tools and these tools. I will just review and launch, just to show you how quickly that thing can be. So basically I have just created a machine called useR. This is the one. It's pending. It will go to starting in a bit and then running. And once it is running, I can take control over the containers that have been created automatically within that machine. So let me pick one of these machines. So you see it went to starting. So basically we used your keys to proxy you with Amazon and get this stuff to run. I will select the Educate machine and go there, and here I'm inside the workbench where I can get very generic widgets, like for example, I would like to work with RStudio. So this is RStudio in the browser, of course, on top of which we have added all the access control, all the security, everything. You could have this RStudio backed by all the artifacts that are needed for a specific course and get a baseline to be reproduced by students in one click. Of course, RStudio is just one among many, many other tools. For example, if I would like to have just simply an access through VNC, here I have VNC, the container. And inside the container, I can basically do whatever I want. So here, the containers have never looked and felt like machines as they are today here in this platform. So basically, I can also ask to use tools such as Jupyter. So this is Jupyter Notebook within a Rosetta Hub, within the container inside which lives RStudio and the other tools. This is Jupyter. I will close these. And I will move to the workbench of Rosetta Hub itself. Here I have the console. So this is another IDE. It's an IDE designed for collaboration, designed for mobile devices, designed for the cloud. It's cloud native. So basically here I'm going to define a variable X. I'm going to define a variable Y. And I'm going to plot X against Y. And at this stage, I will go and say this session, I would like to make it accessible to other collaborators. So this is, for example, one of my collaborators. And also, I will make it accessible to the public. Share. Here we go. So this is a link that those who have internet in the audience, I guess almost no one, can just use. So this is the link. It's very simple, 2UN7LH3. Anyone who connects here would find himself or herself in this environment. So I will do it. I shared with a specific user whose name is C4RR, who is connected here. In shared engine, the user sees that there is an Educate EC2 shared by Kareem that has been made available. So by connecting, the user has access to the same session at the same time. Here we go. I will make them smaller so that you can see. Yeah, and so all my actions here, I will plot X instead of X against Y, and I will annotate. So everything I'm doing on the left or on the right is broadcasted. This is real-time collaboration. I can ask for other widgets. For example, I will ask for a notebook cell. And this notebook cell, basically, it's floating. I can arrange them to be like a notebook, linear, but I can have them floating. I can dock them in spreadsheets. In this notebook cell, I can say, now I'm going to write some R, or now I'm going to write some Python. Let me write some Python. I will define a variable Z equal 4567. This is Z. I will execute this code. So the variable has been created. I can go to the console and see the value of Z. You see, Z is this vector. I will move back to R and say, okay, R and Python here are living in the same memory. They have almost, basically, they are sharing their workspace. So I will say to R, please go and get that variable from Python. I will just say engine.getObject. The variable I'm interested in is Z. And the context, so here everything works with contexts. The context is equal Python. Okay, let's make this bigger in order to see something. This is what I'm doing. I am saying, please R, go and get the variable which name is Z from the Python context. And now the variable became a variable in R. So I can just say Z equal, and this is my Z variable. Now what I can do in this environment is things like, I would like now to represent the variable Z with, let's say, a chart. This is a chart of Z. So I'm asking for visual widgets that will show my variables Z inside the environment. This is not the chart I wanted. I want more of a bar chart. Here we go. So basically, this is like kind of next generation Shiny, where you have the widgets that map your variables in R or Python or Scala or whatever that you create on the fly without defining a client and a server. You just say, I would like a widget that mirrors this. And I would like a reaction on this event of change of variable. And I would like, and you put all these together, and then you get an interactive interface. Okay, so I will make a slider that maps a variable n in R. So I have now a slider that maps my variable n, and I will ask for a macro that will react on n, and it will recompute Z as being a function of n. Here we go. So if n changes, please execute this code. And in the context, I can say this is going to be executed in the Spark context, or in the Scala context, or in the Python context. So let's say OK. And now I have an interface where the change of n is recomputing z, and that recomputation is visualized by that bar chart. Now, n can be changed from interactively, like here, or could be changed from anywhere we connect to the engine. Here you see I'm connected to the engine for a local command line in R. You have almost 700 functions here to manage clouds, containers, and tools that run remotely. So here from my local environment, I will do the following. I will say, OK, now I would like to play with n. So let's put it here. Or I will define a local n, let's say, n equal 50. And I would like to make n, to push n from my local environment to the remote environments. By pushing n, you see n50 went to the remote environment, and that triggered the macro that recomputed z that is visualized here by the widget. At any point in time, anyone who has the link is seeing what I'm doing. I will conclude with just, this is basically one of many ways to access the platform. Here, this is the spreadsheet I showed you earlier in the, on the slide. So all I need to get my Excel remote control containers and clouds is to say, OK, connect. Here I give my session, and then Excel becomes a mirror. And I can do R and Python and Scala within Excel. I can define formulas in Excel that are marked by R. I can mirror cells in the cloud to Excel. All this is real time. You don't have to do anything. It's there out of the box. And basically, that interface I have just created in no time, really. I can snapshot it and put it on the marketplace as a token. So a token is made of the description of this interface, the container that backs it, any tools and files I have added, and inside that marketplace, I will find products. Basically, the product would be my Shiny app that would be reconstituted. So these are products that you can buy and acquire, and anyone who acquires this gets the Shiny app rebuilt from scratch. Acquiring it in general is going to be free, but if you would like to sell your notebooks or your Shiny apps, you can put a price on them, and the marketplace handles for you the transaction, basically. Just give the platform what's your PayPal account or something. I will stop here. Thank you so much. Sorry for the
I think we should thank the speaker and hold your questions until the brunch break.